Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. We've got this aluminium pan. We want to find the outer temperature. They give us the inner temperature, 106 degrees Celsius. It generates power, or uses the power of 701 watts when it is boiling water at a steady rate. We've got the thickness of the pan, which is 0.7 centimeters. The diameter of the pan is 22 centimeters, and the thermoconductivity is 237 watts per meter per degree Celsius. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. Here's the pan. The diameter is 22 centimeters. Thickness 0.7 centimeters. And then the inner surface temperature is 106 degrees Celsius, and it uses 701 watts to boil water at a steady rate. Step 2, list all the given variables, find the unknown. We don't need to go over the variables. They have been listed in the question and in step 1. So find the unknown. We want to find the outer temperature. So T2 will be the outer temperature, and T1 will be the inner temperature. So step 3, find the heat transfer formula. So in this case, we're going to be using the heat transfer of conduction, because we've got an aluminium pan and we're boiling water, so the water is touching the surface of the pan. Okay, so we start off with the formula. We're going to split the delta T into its components, T2 and T1. We're going to rename T2 and T1 just to make it easy for the students so they don't get confused. Okay, so T2 is equal to the outer, and T1 is equal to the inner temperature. So L is your thickness. A is the area. We need to find that. They give us the diameter, so we can find the area of a circle. And they give us K, the thermoconductivity, and they give us the power, or heat transfer rate, which is 701 watts. So almost everything's given. We just need to find two things before we can find the outer temperature. So find the area formula. In this case, it'll be a circle. We're going to assume the aluminium pan is a perfect circle. Okay, plug and play. So make sure you convert your diameter from centimeters to meters. This is important because you want to cancel out your units. Okay, so pi multiplied by 0.22 meters squared divided by 4 gives you 0.038013 meters squared. Step 5, we want to find the outer temperature. So we just plug in everything and we'll find the outer temperature. So your left hand side is your heat transfer rate, your power. And then your right hand side, you've got your thermoconductivity, your area, your unknown, which is what we're trying to find, and then the inner temperature divided by the thickness. Okay, so when you plug that into your calculator and solver, you will get 106.54 degrees Celsius for your outer temperature of your aluminium pan. Alright, disclaimers, the method is correct. However, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answers. Before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down while I follow all copyright laws. Sometimes things happen. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. Click on the icon in your taskbar. If it's not in your taskbar, go to your Windows search, type in snipping tool, open up the program. Once open, click on video option, then click on new. Left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button in snipping tool, wait for the countdown. Hit the replay button on YouTube, let the video finish. Hit the red square in snipping tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.